Fermat's last theorem. 125 equals 126. What? Plain honesty, simple truth, easy understanding. The joy of finding things out for yourself. Even if you are only a minority of one, the truth is the truth. Mahatma Gandhi. Since 9 cubed equals 8 cubed plus 6 cubed, and 9 equals 6 plus 3, then 9 cubed equals 6 cubed plus 3 cubed plus 3 times 6 squared times 3 plus 3 times 6 times 3 squared. Therefore 8 cubed equals 3 cubed plus 486. Since 3 less than 8, let 8 equal 3 plus 5. Therefore 8 cubed equals 3 cubed plus 5 cubed plus 3 times 3 squared times 5 plus 3 times 3 times 5 squared. Therefore 8 cubed equals 3 cubed plus 5 cubed plus 360. Therefore 5 cubed equals 486 minus 360 equals 126, thereby proving that 125 equals 126, QED. The reality is that 9 cubed equals 8 cubed plus 6 cubed plus 1 cubed. What we have done is to numerically confirm that the algebra given in my other YouTube presentation, a demonstration of the absurdity of the Fermat equation, is factually correct, and it is self-evident that the algebra would apply to any Fermat equation of any power, just as it does for the Pythagorean triples. If one could ever exist, that is. In his book Fermat's Last Theorem, Simon Singh acknowledges the fact that the sum of two cubes narrowly miss being equal to a cube by plus or minus 1, but evades the fact that there are infinitely many of them and that cubic quadruples are the subject in themselves. There is no discussion regarding any implications they may have had for Fermat's last theorem. He is, however, happy to push quartic quadruples in our faces in support of the notion that there are infinitely many large monsters out there waiting to pounce on us, in support of the notion that it can only be avoided by proof obtained using the tools of modern mathematics. What nonsense! Another reality is that 1. Every cube is the difference of two adjacent triangular numbers squared. That is, 28 squared minus 21 squared equals 343 equals 7 cubed. 2. We can repeatedly multiply through by 7 squared to give every integer raised to every odd power as the difference of two squares. That is, 7 squared times 28 squared minus 7 squared times 21 squared is equal to 196 squared minus 147 squared is equal to 16,807, which is equal to 7 squared times 7 cubed, which is equal to 7 to the 5th. So if we can't elevate the difference of two squares for the cubics, then we certainly can't elevate it for any other higher odd power. It is also counter to the laws of indices. 4. The minimum known all-integer expression for the quintics is 144 to the 5th is equal to 133 to the 5th plus 110 to the 5th plus 84 to the 5th plus 27 to the 5th, and is the reason why Euler made his famous sums of power conjecture, which the quartic quadruples proved false. The nearest thing to a quintic Fermat equation I know of is 237534551 times 3 to the 5th is equal to 133 to the 5th plus 110 to the 5th. What grounds has anyone to say Fermat didn't have the tools for his proof?